Hi, I am Dr. Harikrishna Mulam, Associate Professor, Department of EIE, VNR VIGNANA JYOTHI. In this lecture, we will solve one more problem related to time response analysis. Please play the video at 1.5x or 2x speed to save some time. This is the problem. In this problem, they are stating that the considered system is a unity feedback system. So the feedback transfer function is a unity. Such a feedback control system has an amplifier with a gain of Ka is equal to 10 and gain ratio means it is ratio of Laplace transform of output by Laplace transform of input, output by input. Therefore, which can also be represented as open loop transfer function G of S, and it is equal to 1 by S into S plus 2 in the feed forward path. So, for this unity feedback system, in the forward path, we have two blocks. One is an amplifier and the another is a system with a gain ratio of G of S. Therefore, let us draw the block diagram of this system. So, as already discussed, this system has an amplifier with a gain Ka is equal to 10 in the forward path, as well as it also has a gain ratio represented by G of S is equal to 1 by S into S plus 2. After that, it is said in the problem statement that a derivative feedback H of S is equal to Sk naught is introduced as a minor loop around G of S. So, as per this statement, there is a feedback around G of S. Okay, there is a feedback only around G of S and it is equal to Sk naught. Therefore, here if there is a feedback around this G of S as minor loop, we can represent like this. This is the minor feedback loop. H of S is equal to Sk naught. And if it is the feedback for this G of S, okay, this part of the system is drawn like this. This part of the system is drawn like this. Unless specified, the feedback is considered to be negative. Therefore, here it is minus. So, as per the problem statement, in the forward path, the system has an amplifier Ka is equal to 10 and it also has a gain ratio G of S is equal to 1 by S into S plus 2. But this gain ratio has a feedback, okay, which is equal to Sk naught. But this amplifier and this gain ratio, they are in series, they are in forward path. Therefore, we need to join like this. And this is the system, total system, and for which the feedback is unity. Therefore, once again, you need to show one more feedback. Okay, feedback for the entire system. Feedback for the entire system, which is unity feedback. And again, as we did not specify anything about whether it is positive feedback or negative feedback, by default, we consider negative feedback system. So this is R of S, input to the entire system. This is C of S, which is the output of the total system. So if you draw the block diagram of the system whose information is given in this problem, okay, it looks like this. Now what is that we need to find? We need to determine the derivative feedback constant K0. This K0 we need to find, so that the damping factor is 0.6. So the damping factor zeta should be 0.6, and if the zeta is 0.6, what is the corresponding derivative feedback constant which is represented by K0 here? Okay. So first of all, what we need to do in such problems is you need to find the transfer function of the entire system. Okay. And let us see how to find it. So before finding the transfer function of the total system, okay, let us find the transfer function up to this extent. Here G of S is the forward path and Sk0 is the feedback path, and let us try to find the transfer function of this part of the system. Therefore, transfer function of that minor loop, okay, we are calling it as minor loop. This is the major loop, okay, where the feedback is unity. So the transfer function of this minor loop, transfer function of minor loop is equal to, formula is same. Here it has some transfer function in the forward path G of S. In the feedback path it has transfer function H of S. Therefore the formula is G of S by 1 plus G of S H of S. That is equal to, G of S is 1 by S into S plus 2, which becomes S square plus 2S, whole divided by 1 plus G of S is 1 by S square plus 2S into H of S for this minor loop is equal to Sk0. If you simplify this expression, transfer function of minor loop is equal to, if you simplify this, you will get it as numerator is 1 and the denominator will be S square plus 2S plus Sk0, which can be written as 1 by S square plus, if you take S common between these two terms, it will be 2 plus K0 into S. This is the transfer function of the minor loop, and this transfer function is in series with this amplifier, which has a gain of 10. Therefore, transfer function of feed forward path of this system is equal to, simply this amplifier is in series with this entire minor loop. Therefore, overall transfer function of this forward path will be the multiplication of individual transfer functions. Therefore, this 10 into whatever is the transfer function of this minor loop. Therefore, 10 into 1 by this 1 by S square plus 2 plus K0 times S. Therefore, it is 10 by S square plus 2 plus K0 times S. For such a forward path, the feedback, this one is, let me say, as we have already used H of S already in this system, let us say this as H1 of S is equal to 1. Therefore, the total closed loop transfer function of this system is equal to transfer function of feed forward path divided by 1 plus the transfer function of feed forward path into H1 of S. That is equal to 10 by S square plus 2 plus K naught times S whole divided by 1 plus transfer function of feed forward path 10 by S square plus 2 plus K naught times S into H1 of S is 1. If you simplify this, you will get it as 10 by S square plus 2 plus K naught times S plus 10. So this is the transfer function of this entire system. This is the transfer function of this entire system. Now, it is given that the damping factor is 0.6 and you need to find the corresponding K naught, which is called as a derivative feedback constant. In order to find that, always compare denominator term of the transfer function with standard denominator term of a second order transfer function. So we know that second order transfer function is represented as omega n square by S square plus 2 zeta omega ns plus omega n square. Compare this denominator term with this denominator term to find omega and zeta. Therefore, if you compare, we can understand that omega n square is equal to 10. Therefore, omega n is equal to square root of 10, which is equal to 3.162 radians per second. And similarly, if you compare this 2 plus K naught times S with 2 zeta omega ns, you can write 2 plus K naught is equal to 2 zeta omega n. Therefore, K naught is equal to 2 zeta omega n minus 2. That is equal to 2 into zeta is given as 0.6. Omega n we found it as 3.162 minus 2. This 2 into 0.6 into 3.162, it comes around 3.7944 minus 2, which is equal to 1.7944. Therefore, K naught value is equal to 1.7944 in order to have a damping factor of zeta is equal to 0.6. This is how you need to solve this problem. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.